Good afternoon, everyone, and welcome to today's webinar. We're having a masterclass on retrofit, looking at across the whole gambit of construction. I'm Scott McGibbon. I'm Managing Director at Pvotal Consultancy. We've been working closely with BEST to help develop their low carbon learning programme, of which today's masterclass is one. There'll be some links later on as we move towards the end of the webinar that will allow you to actually take a deeper delve into the various learning content, the various modules, webinars, workshops that are available, and these are all free. And hopefully after today you'll leave feeling more confident, have a bit of value with regards to retrofitting, what it means to you as a business, what it means to you for your projects, and what you need to do with regards upskilling, reskilling, and your competency requirements. But before I get underway, I'd just like to do a little bit of housekeeping just to make sure that the webinar runs smoothly and that you have as much information as possible. So today's session is being recorded and it'll be able to be viewed on BEST YouTube channel at some point next week. And if I can ask you that all participants remain on mute during the webinar, but feel free to drop questions into the chat box, whether it's a question or whether it's an opportunity to share your own experience or your own struggles in the retrofit area. So to do so, all you do is click on questions in the control panel, type in your question, and then press send. And we'll try to answer as many as we can during the question and answering session at the end. If you can try and, if there is any other questions that we don't touch on, we'll collate them and we'll sift through them, and then we'll push them out to our experts today, and we'll hopefully give you some valuable answers. We'll also be in between the speakers, we're looking to have some interactive polls, and these will be displayed on your screen. And the whole idea is they won't want to get your feedback. We want to actually look at developing these programs that we've initially started. So without further ado, I want to introduce you to our first expert. He's Dr. John Stinson. He's Managing and Technical Director at the Building Research Solutions, and he's been Chair of the Chartered Institute of Architectural Technologists in the Scotland East region. Over the last 15 years, he has published a number of publicly available technical, academic papers surrounding refurbishment case studies, conference papers, journal papers, all on the topic of energy efficiency retrofit. And from 2010 to 2015, he contributed significantly to the development of what we now know as BEST. Today, John is sharing his knowledge on the life cycle assessment and how this can be used effectively and to support retrofit projects. So without further ado, John, if you want to take it away.
Superb, thanks, Scott. Yes, I'm indeed Dr. John Stinson, and I'm here to add my voice to the learning material for retrofit, repair and maintenance for the improvement of traditional buildings. As Scott has said, I've been working in this domain for quite a while now, and I've covered retrofit in a number of different ways. But today I want to focus on life cycle assessment. So the thing you'll come to understand about life cycle assessment, or LCA, is that it's very broad, and it can be used to calculate the climate and environmental impact of almost anything. But today I'm going to keep it specific to the construction sector and the energy efficiency retrofit of Scotland's pre-1919 traditional archetypes. So I will very briefly cover the steps involved in LCA, then how we would evaluate the operational energy consumption and demand and plug that into the LCA, and then I'll bring it all together and describe how an LCA is used for decision support making within your retrofit project, and then I'll have a couple of slides throughout talking about further reading and other learning resources. But before I go much further, and to add to Scott's note about further learning material, Built Environment Smarter Transformation, back when they were CSIC, in collaboration with CIAT Scotland East Region, held an event that might be seen as a prelude to these low carbon learning programme. So BEST, myself, Historic Environment Scotland, and a speaker from a secondary glazing company spoke on the importance of repairing, restoring before retrofitting. So if you've not seen that particular video, I encourage you to please do check that out after today's webinar. So in that webinar, I covered operational energy, and today I want to talk about life cycle assessment and embodied energy performance. So the question before us here today, from my perspective, is how can a life cycle assessment be used effectively in your retrofit projects? And before I break this down into detail, the big take-home message from my talk this morning is that it's really all about balance. There's a very fine line between what energy efficiency retrofit measures are good for the building today and what retrofit measures will be good for the future of the human race in terms of the environmental impact of our retrofit decisions. So we'll start off with why would you even consider doing an LCA in a retrofit project? Well, simply put, a life cycle assessment is a very effective decision support tool that would help to define something that could be classified as wholly sustainable and a sustainable retrofit. So LCA does this in a number of ways. It actively rewards you for shifting your supply chain in support of local skill, local labour, local technologies, and specifying homegrown materials. And it can also ensure that you're retrofitting a building that will be sustainable today and also be sustainable after the end of its life. So if you are taking a building-centric retrofit design approach, where you're evaluating the efficacy of a range of different retrofit intervention measures, then an LCA enables you to do a carbon hotspotting for each of those different retrofit measures to inform you which one will have the least impact on the planet going forward. So at its core, an LCA output is a value. It's either embodied energy or embodied carbon, which tells you the environmental impact of what you're doing, which in this case, what we're doing here is retrofitting Scotland's pre-1919 traditional archetypes. So how do you do that effectively? Well, LCA has 4 steps, and they aren't convoluted, they aren't complex. It just depends on how deep you want to go within your scope. So the first step is to set your scope, and I'm going to talk about scope setting in a few seconds. The second step is to create a life cycle inventory, and this is where you go off and build up a library of embodied energy and embodied carbon values for each of your retrofit measures that you're considering to put into your building. Now, most of that information will come from environmental product declarations, EPDs, and also requires a good bit of knowledge in how you would actually install the retrofit measure. The third step is the assessment itself, and that's simply the calculation stage, where you would calculate the carbon emissions from the whole life cycle of the retrofit material or technology that is being considered for your retrofit project. Step 4 is the interpretation stage, where you start adjusting your decisions within your retrofit measures and see how those change in decisions will affect the overall environmental impact of your retrofit options. So here is where you can start to challenge your supply chain based on what the environmental performance declarations say for that material, or perhaps changing material specification based on the location of its factory to your site, or perhaps you would switch to a material that has a more positive end of life destination other than going to landfill or incineration. And as I mentioned, all of that starts with setting your scope. So when it comes to scope setting for a retrofit project, you really want to set it so that you get the best perspective on the global environmental impacts of your retrofit measures. So in terms of perspective, we in the construction industry are very, very good at estimating and calculating the operational energy demand and associated carbon emissions. But operational energy demand is only one part of one stage of a 5-stage process for calculating a building's whole life embodied carbon and environmental impact. So an LCA provides you with the ability to get the right perspective on how sustainable your retrofit project actually will be. And I guess another thing worth taking away from my talk here this morning is that a truly sustainable retrofit project goes beyond low U values and high COPs for heat pumps. So it's up to you to set the scope and decide how much of the retrofit measures life cycle you want to include in your assessment. Essentially, that means using this well-known LCA boundaries infographic on the screen here. Setting the scope means how much of the retrofit materials or measures life do you want to calculate before the retrofit project is handed over to the client, and how much of the retrofit measure do you want to track during the life of the building. That includes repair and maintenance of that material or technology, and how much of the retrofit measure's journey to its end of life do you also want to track. And when you're seeing all this, you could be forgiven for saying, hold on here a minute, I'm just trying to lower people's fuel bills. What concern is it to me about how my IWI gets to the site, or how the occupants maintain it, or what people do with it after tripped out? And really, that question, therein lies the crux of where we are as an industry. Every energy efficiency decision that we make as designers, installers, or project managers has two main effects. One is the immediate effect on the building's users, which we're all very accustomed to, and the second is a long-term impact on the local and global environment. So as construction professionals, we can do more to reduce global temperatures by critically evaluating the whole life cycle environmental impact of the materials and technologies that we specify and changing our supply chain. We can do more to achieve a sustainable future for Scotland by doing that, more so than if everyone in the audience here today left your office, went out and bought an EV this afternoon. And that's what we are calling short-term gains for long-term wins. Now, I want to talk about the role of the operational energy within the LCA and how that can be used to inform effectively support your retrofit projects. So I've got two slides here, one for retrofit evaluation and the other for retrofit assessment, which are very, very important steps in your LCA. Both of these I've covered in a lot more detail in that other BEST knowledge exchange video I mentioned earlier. Now, I have both slides added to this talk here today because I want to continue to dispel the notion that retrofit evaluation only happens at the end of the retrofit when it's complete. Doing that, having that approach is very wrong and potentially hazardous, especially for our traditional building archetypes. So you use your retrofit evaluation toolbox to establish the baseline energy performance of the building before you even start considering what retrofit measures you should be applying to the pre-1919 traditional Scottish archetypes. Because this archetype, more so than almost any other one, will be a lot more sensitive to how your retrofit measures affect the building's ventilation strategy, the thermal comfort, and also moisture dispersion. So for operational energy calculations, at the very least, you really want to get that insightful energy consumption values that you can get from loggers or more detailed fuel bills. And if you can't or don't want to wait a full year to measure the building's energy demand before retrofit, then you're going to be needing to use other tools like U-value measurement, thermal bridging, thermograms, air permeability, etc., to give you the actual values for use in the next step. And the next step then is retrofit assessment, which does happen only after you get those baseline pre-retrofit values from your retrofit evaluation step. Then, with much greater confidence, you can you build your digital model of your building, digital twin if you like, and run your range of retrofit measures through your model to generate a set of retrofit scenarios. And of course, you'll be looking at other retrofit measures or other effects of the retrofit measures like fire spread, acoustic enhancement, U-value, psi value, temperature factor, moisture dispersion, etc., And yeah, they all do play a very vital role in the decision making for material specifications, but it is the modeled energy demand reduction from the various retrofit scenarios that you'll be using in your LCA. And it's really, really vital to get those actual in situ measured performance values from your actual building, as opposed to assuming values from RDSAP or SBEM and other lookup tables. Right, this is my last my last section. I'm going to bring this all together and demonstrate how the LCA output is a decision support tool to inform a more sustainable retrofit project. So this infographic shows three relationships between embodied energy and operational energy. And this is the kind of crux of my talk here just now. For each relationship, we have two retrofit scenarios, scenario A and scenario B. In the first relationship, the top one there, for a material like a structural material, say for steel. So in this example, say you're extending that 1750s Midlothian cottage and you're using a steel beam system for that Mies van der Rohe kind of extension type of thing. Then scenario A would be a steel beam that would be over-engineered, so it's larger than it needs to be. And scenario B is a steel beam that is sized exactly for the intended purpose. So scenario A, the unnecessarily larger beam, will have larger embodied energy value because more steel was manufactured, more was transported just to do the same job, and then there's a lot more steel to get rid of at the end of its life. So for both scenario A and B, if detailed and insulated correctly, the size of the steel member will have little to no bearing on the building's operational energy, but it will have higher embodied. So there's a clear winner there. You go for the size of beam that's appropriately sized. The next relationship is directly proportional. That's that middle one there. Here we have, let's say, an 1840s tenement flat. But let's say it's the middle of nowhere and no one is giving you a hard time about removing the sash and case window. So scenario A would be a timber frame window with a U value of say 1.4. Scenario B would be a steel frame window with a slightly higher U value, say 1.8. Here we are assuming that the manufacturing process and end of life scenarios are more sustainable for timber than for steel. So when you're looking at embodied energy, the wooden frame window has a lower embodied energy value compared to steel, which is good. And then when we look at operational energy, the energy consumption, the timber frame's lower U value is better than the steel frame's higher U value. So scenario A is a clear winner. So it's good for the building just now and it's good for the environment longer term. The last relationship between embodied energy and operational energy is what we call inverse proportionality. Now here, our example is based on the thickness of internal wall insulation. So say it's phenolic foam or something like that. Scenario A uses 50 mil of insulation and scenario B would use 150 mil of insulation. From an embodied energy perspective, the thinner insulation will have less mass. So there's less to manufacture, there's less to transport, there's less to install, and importantly, there's less to get rid of. But with insulation, whose performance is predicated on the thickness, where the thicker the insulation in scenario B will provide a lower operational energy consumption from the building. This is what we call the inverse proportionality, which is really the most common type of relationship you see in retrofit projects. And this is what makes LCA the most valuable tool, because in this instance, there's no clear winner between thicker and thinner insulation, because one's better for the building today, but one's better for the environment longer term. So your LCA will tell you if those differences between operational energy savings will ultimately justify the larger environmental impacts seen in embodied energy. So the LCA is here not just to tell you the environmental and sustainability impacts of your retrofit measure today, but it'll also tell you how that retrofit measure will impact the environment in the longer term. Right, so this is my second last slide, and these last two are very, very quick, so I'm going to wrap up just now. So coming back to our original question at the start of the slides, how can an LCA be used effectively in a retrofit project? So the thing to be aware of is retrofit is almost always better than knocking the building down and starting again. There is something called plot renewal, which I've not talked about today, but that's something definitely worth considering for non-traditional archetypes in Scotland. LCA allows you to make more informed decisions because it is by design a decision support tool, and it's also there to allow you to do carbon hotspotting, which enables material optimization to challenge your supply chain. And retrofitting energy efficiency measures is all about balance, and an LCA allows you to strike that balance between measures and materials that save operational energy and those that will help you save embodied energy. Right, so this is the last slide. Just very quickly, it would be wrong of me not to provide some links to other sources for further reading and more materials. There are some, you can have a look at those in the future: software, databases, resources, and ISO standards for LCA. Right, with that, I'm going to pass back to Scott.
Thanks for that, John. Thanks for that excellent presentation. Very informative, and I'm sure everybody agree that it was really quite insightful in what we need to do for life cycle assessment. So with what I'd like to do before I introduce the next expert is actually, if we have an interactive poll, and if you can, we'll spend a couple of minutes, and once you've filled in the poll, we'll head on over to our second expert. So I'll just give everybody about 30 seconds just to complete the poll, and then we'll move on to our second speaker.
Thanks, Scott. Poll completed.
Okay, now I'd like to introduce our second expert, and that is Jonathan Bourke. Jonathan is the Retrofit Centre of Excellence Manager at Warmworks, and within his role, his critical role within the Centre of Excellence, he ensures that there's a management of robust audit processes, interrogation, and accurate reporting on the outputs of retrofit assessors, coordinators, designers, and installers. So in this presentation, John's going to look at the competency requirements and what the implications and what the benefits, the value that brings to you as a business and also to your projects. Jonathan has a background in accreditation with his former employers, Elmhurst, and he has his own personal registration with Trustmark. So he's a well-placed subject matter expert to give us a wider insight into the mobilisation of works to meet the current PAS 2035 standards. So, Jonathan, if you could take it away, please, that'd be great.
Thank you very much, Scott. Thanks very much indeed. No pressure then, eh? So yes, good morning, everyone. Thank you for coming along today. As Scott has mentioned, I'm the Retrofit Centre of Excellence Manager with Warmworks. I've been with the company for just a few weeks. Prior to that was with Elmhurst Energy, one of the accreditation schemes within the world of energy assessing and retrofit. And here with you today to share some considerations around the mass rollout of retrofit programs of work that we're involved in. I'll give you a brief overview of our role as a managing agent, but I'd like to also introduce a few definitions from the PAS 2035 document, especially around traditional buildings. Interestingly, for many people, a traditional building can mean lots of different things. For some people, it's an older building, or it's a historical building, or it's pre-1919, or it's a vapor open construction. Sometimes the traditional building can be looked upon as what it isn't in terms of non-standard construction, and that can cause a bit of confusion out there, because non-standard, non-traditional construction might be referred to as system built with an energy assessing methodology. So for the benefit of today, I will be using the PAS 2035 definition of a traditional building and run through that with you. We'll also look at the assessment process in a couple of ways. So the risk assessment that's done as part of any retrofit programme of work compliant with the PAS 2035 standard, and the retrofit assessment with what I would suggest would be the 6 main purposes of assessing a property compliantly. We'll then explore in a bit of detail the implications when it comes to assessing a property of traditional construction, and have a wee look at a skills matrix I've put together for you when it comes to the design of the package of measures we're looking to install. And then I'll leave you with a nice wee handy tool, which I hope will be of use to you going forward. So, who is Warmworks? For those of you who don't know, well, we're a managing agent, which means that we manage the full end-to-end installation and quality inspection of heating, insulation and energy efficiency improvements in customers' homes. Now, we do that through managing a network of now up to, I believe, around about 30 registered and accredited subcontractors who operate as our supply chain. We do have our own retrofit assessors in-house who'll be the boots on the ground out there, generally towards the start of the programme, conducting the assessments on before we engage our supply chain to actually go out and install the measures in a compliant manner. We do inspect every job that's conducted, both mid and post-install. And we also have quite a part to play in terms of the support of local communities in which we work, and again that's through both directly and our supply chain. And since Warmworks was formed in 2015, we've actually been responsible for the creation of more than 150 apprenticeships, more than 700 jobs and 3,000 training opportunities. And a bit of context there in the middle, that we were formed as a joint venture partnership between the Trust, Everwarm and Changeworks. To give you an idea of some of the projects we're involved in, they're listed there on the right hand side of the screen, but to highlight 2 main ones within the world of retrofit, we have the Warmer Homes Scotland scheme, which is the Scottish Government's National Fuel Poverty Programme, which we've been delivering since 2015. Although that's not to PAS 2035 standards at the moment, it does involve multi-measure retrofit work, and you can see there on the map an idea of some of the places where we've conducted projects, and we do cover every postcode in Scotland. But in terms of PAS 2035 compliance, that's come to the fore in our involvement in the Sustainable Warmth Programme on behalf of the Greater South East Net Zero Hub. I've taken a snip there of the map of the geographic area. You can see that covers from Berkshire in the west right out to East Anglia, and from Northampton right down to the Kent coast. So it's a huge area with obviously the logistical challenges that brings to deliver on projects within that area. And a fascinating fact for you, 46% of all existing dwellings in the UK are located within that geographic area. So we do come across lots and lots of different types, lots of different archetypes. The sub-schemes, if you like, within sustainable warmth are aimed at predominantly owner-occupied homes and private rented sector. And you may be familiar with the LAD scheme and the HUG scheme, and they are both component parts of sustainable warmth. Now, a wee bit about the definitions. The first one there, what's referred to in the PAS as presentational conventions. I want to publicly thank my former colleague, Simon Flint at Elmhurst Energy. We had a good chat about this. Reading the PAS occasionally is very reminiscent of those days of looking at the highway code, where we talk about should and shall and things that must be done. So in terms of the definitions today, anything that's referred to within the PAS as should is recommendation, it's best practice, it's guidance to follow, whereas shall is an absolutely explicit requirement to comply with the PAS. That had come about when we looked at the scope of retrofit assessing, when there was a lot of chatter out there in the industry about a requirement for retrofit assessors to arm themselves with anemometers and go out and measure the flow rates of existing fans within properties, which I should emphasise is a should and not a shall, as the PAS currently sits. But the crux of the matter, traditional construction. So what is a traditional building? There's the definition, lifted straight from the PAS. Solid brick or stone external walls, or pre-1919 timber framed external walls with any infill. Okay. If you want to compare that against some of the other definitions in the PAS, the other construction styles that are detailed are either conventional construction or system built construction. And that will form the basis of some of the things I'll mention later on. Another thing to highlight is a protected building is defined in the PAS, and essentially that's listed regardless of the category or grade, or the properties in a conservation area, or it's located in a World Heritage Site. And this is quite obviously more common than you think, especially working in such a large geographic area as the southeast of England. Many of the customers we deal with, given the nature of the scheme, may be classed as vulnerable. For some people, English may not be their first language, for example, also. So there's only so much work that can be done in advance on a desktop basis. This is invariably going to come down to the skill of the retrofit assessor and how competent they are to identify a property, or if they've found themselves in a conservation area. And again, World Heritage Site is a bit more common than you think as well. I would always instinctively think of the pyramids of Giza or something like that. But interestingly, if you stand on the Royal Mile and you look up at Edinburgh Castle, look left and right, all those flats above the shops, you're standing right in the middle of a World Heritage Site. So it's worth keeping that in mind, that the scope of the protected building. We then have this occasional confusion that can crop up over the retrofit designer and who is the person who actually designs the package of measures or the individual measure that's going to be installed within a property. Although it's a defined role in the PAS, it's not a job as such. It's more involves the collation of a lot of information, so that the retrofit coordinator will work with people who are skilled and competent to produce designs for either individual measures or a package of measures within a property. It will take into account the outcome of the retrofit assessment and the information that's been gathered through the photographic evidence, site notes and so on that have been collected at that point. The person, the designer, will appreciate whether any ventilation has to be upgraded as part of the process. And when I come to the skills matrix later on, I'll expand on that in a bit more detail. Now, risk assessing, I mentioned at the top, this is something that's worth clarifying when we move into the world of traditional buildings. So PAS 2035 provides retrofit coordinators with a nice handy ready reckoner that they can use when they begin to look at a programme of works in terms of categorising the risk associated with the installation of the energy efficiency measures. Now, the measures, the individual measures themselves, will each carry what's known as an inherent technical risk, and that can influence the particular path that's followed. And as you can imagine, on a scale of A to C, as you move further up the risk rating, that tends to place a greater focus on the compliance standard that's being followed through that individual project. But traditional buildings are always a minimum of a risk grade B, as you can see there towards the bottom, and protected buildings always a grade C. If not higher, a traditional building may be classed as a category C, depending on the number of measures, for example, that are looking at being fitted. But one thing I would always emphasise is the dynamic nature of a risk assessment. Any student of retrofit will be familiar with expressions to do with corners, junctions, edges and interfaces, for example, which naturally leads to considering where the wall meets the roof, where the wall meets the ground, etc. How the EWI will interact with the loft insulation that's being installed. We consider that around considerations of thermal bridging, for example. But there are a couple of other interfaces which have to be appreciated as part of the process. The first one being the building services. So if we're looking at an installation of a fabric measure, but also a heating measure, so say an air source heat pump, how will those interact, and in what way will it be designed and specified to take into account that the house might have a lower heat demand in the months ahead following the installation of fabric measures. And another interface which has to always be front and centre, I would suggest, is to do with the occupant and how the person living within the house uses energy at the moment, any changes that are likely to happen in the years ahead, how familiar they are, how complex the systems that we're looking to install may be, and how they'll be able to operate and live a nice, comfortable life within the property. And that all feeds in from what's gathered during the retrofit assessment. So these are the half dozen or so critical component parts of that. An energy assessment is conducted by the retrofit assessor, who is a domestic energy assessor who's upskilled to be qualified and accredited as a retrofit assessor. They'll conduct that RDSAP assessment looking at the asset itself, the heating and hot water system and the lighting. We instruct all assessors to export that detail into full SAP so that the retrofit coordinator can conduct various calculations through part of evaluating the various options. For any certified passive house designers among you, PHPP is acceptable within the PAS. I mentioned about the occupancy assessment, especially if it's a vulnerable person, but it will also introduce heating pattern detail and how the person within the house uses appliances, how much they spend on fuel. And the overall purpose of that is to meet the intended outcomes that have been set at the start of the programme. So whether that's a reduction in demand for energy, whether it's a decarbonisation programme, whether it's to improve a SAP score, there's always going to be various drivers or combination of drivers involved in a programme. And it's within the occupancy assessment as part of the retrofit assessment itself that will begin to add a bit more flesh to the bones on that, which in turn will lead to what John was chatting about earlier when we come to evaluate at the end of the process that the work has met the intended outcomes. Now, condition reporting is conducted by retrofit assessors. It may or may not be a chartered building surveyor. They're not there to operate naturally in that same capacity, although, as I say, chartered building surveyors, many of them have subsequently upskilled as retrofit assessors. And the information is reported back to the retrofit coordinator and the project team is predominantly around any structural issues or damp, mould, condensation that's identified, but in particular any remedial work that has to take place. It's important that the project team look at treating the cause and not the symptom of anything that's been identified. We had a job recently where it turned out it was external drainage that was causing a damp problem within the house rather than the fabric of the building. So very often it's having that holistic approach at looking at what can be done to improve it across the board. And as a step up from the world of conducting EPCs, a condition report should consist of thoroughly detailed site notes, photographs and floor plans. Looking a bit broadly at the property, the context is critical in terms of the setting and its location, any planning considerations that may need to be accounted for throughout the installation, the exposure to wind-driven rain, for example, and critically the ventilation that's currently in place within the property must be documented and assessed, and that will in turn inform whether a ventilation upgrade is required as part of either the installation of fabric measures or air tightness measures, for example. And then lastly, significance survey. I'll give you a bit more information on that. I'm not going to go through this line by line, you'll be pleased to hear, but this becomes more and more relevant when we move into the world of traditional buildings. So, protected, back from what I mentioned earlier about listed, conservation area, World Heritage Site. If it's a protected building, the retrofit assessor attending site must hold the level 3 energy efficiency measures for older and traditional buildings qualification, and a full assessment shall be carried out in accordance with BS 7913. But for traditional buildings more broadly, as defined by the PAS, an assessment of significance shall still be carried out. However, the BSI have produced a simplified version of the significance assessment to allow retrofit assessors to conduct that on site. That's all fed back to the project team, who will review that and take that into account when it comes to designing retrofit measures, and then in advance of any pre-installation building inspection which will take place. And if there's a likelihood of the retrofit measures impacting on an aspect of the building identified, a heritage impact assessment should be conducted as well. Now, I haven't seen Moses' presentation, so I'll not rain on his parade at this point, because I dare say he'll chat a bit further about the significance of traditional buildings. But broadly speaking, those 4 categories I've listed there at the bottom should give you an idea of the key values that are considered by a retrofit assessor on site. Put together this skills matrix, folks. Again, I won't go through that in particular detail, but there are just a few key takeaways. I mentioned the retrofit assessor working on a protected building must hold that level 3 qualification. There'll always be a Path C job by its nature of being a protected building, but it becomes particularly relevant when we look at the retrofit designer. So there are certain instances where a retrofit coordinator, for example, can act as the designer if they're suitably competent, or they may engage with, for example, a member of the Chartered Institute of Architectural Technologists. But as we begin to move into more and more traditional properties, there is a requirement on Path B jobs, as they'll all be as a minimum, for professional retrofit retrofit designers who are members of a chartered body to hold the level 3 older and traditional qualification, or to be a member of the respective conservation scheme. When we move into the world of Path C jobs, the membership of the conservation scheme begins to become mandatory, whether that's a traditional building or protected building. So the key takeaway from that, if you're a contractor, or if you're a managing agent, or anyone involved in the overarching project management of the delivery of PAS 2035 compliant works, you must engage with chartered architectural technologists, architects, builders, chartered surveyors, engineers, whoever has the relevant competence to be able to produce and review the designs and to assist the retrofit coordinator accordingly. And that particularly becomes relevant when we look at evaluating the project, so how well we've delivered on the intended outcomes of it. And as you can see at the bottom, there again, that qualification that Moses delivers pops up yet again as a mandatory requirement. But the good news for any budding retrofit designers among you, members of a chartered body who are perhaps considering where would we begin with this, there are a couple of tools out there available. My own personal favourite is the Sustainable Traditional Buildings Alliance Guidance Wheel for Design. It is a dynamic website that you can access through that link at the top, and you can play around with that. So there's a drop down there where you can put in various different types of heritage or exposure status, for example, to the property. But when you begin to look at individual measures, you'll see on this one that I selected looking at upgrading the walls and also the doors. And you can see this begins to make suggestions in terms of the interaction of measures bringing in some technical concerns as well as heritage and energy. So have a wee look at that website in your own time, and I hope you'll find it as useful as I have. So thank you very much. Hopefully I've managed to stay on time, and I'll be delighted to answer any questions you may have. Thank you.
Thanks for that, Jonathan. Again, another excellent presentation and some really good insights into the current pass standard and some insightful comments with regards future skills and competency requirements, which hopefully will help everybody at today's webinar. So before I move on to our final speaker, and by no means least, I would like to everyone to undertake our next poll. So I'll give you about 30 to 60 seconds to complete.
Just while people are filling out the poll, unfortunately Moses is unable to join us today. He's having some connection issues, so we'll go into our Q&A next, Scott,
Okay.
and Moses will send through some information, but he sends his apologies.
No, that's not a problem. That's not a problem.
Thank you. And I'll just close the poll now for everyone
Yeah,
to...
yeah. So unfortunately, I've just been informed that our next speaker, who was going to be Dr. Moses Jenkins, who's Senior Technical Officer at Historic Environment Scotland, is having some technical issues. So what he has suggested is that if there are any questions that you would like to post to him, just drop them into the chat. He'll send over his presentation, and then we'll farm it out at a later date to all attendees. We'll have all your emails, so all the learning content from today's webinar will be pushed out to you. So I think, which makes sense, I think we move on to sort of a question and answering session. So if there is any questions, as I said, just drop them into the chat box and we'll go through them. So I'll just give you a couple, 30 seconds or something just to come together. So we've got a question here from Jennifer, and it's for John. She would like a little bit deeper explanation of plot renewal, and is there another term for demolition or new build?
Thanks, Scott. Yeah, thanks for the question, Jennifer. Essentially is what you've described it. You would knock the building down to its subfloor. It's keeping its foundations, keeping the concrete base, keeping connections to existing services, electricity, gas, water, sewage, that type of thing. And a project I was involved in a long time ago, up in Fife, we did an LCA comparison. We did a building performance evaluation comparison between deep retrofit, plot renewal, and new build. And the deep retrofit was at the time applying Section 7 of the Scottish Building Standards, well, a variation of Section 7 of Scottish Building Standards that achieved gold, silver, bronze, but as a retrofit, which was also a great learning experience. And the reason why plot renewal could be better for some of Scotland's non-traditional archetypes and some of the definitions that Jonathan used earlier is sometimes it's just not as effective to deep retrofit them because you can end up losing quite a bit of floor space with the insulation you need to add in, or you can't get the ventilation system in because of floor ceiling heights, etc. Where plot renewal beats out new build is that you're keeping all the concrete in the foundations, in the subfloor, anything up to where you can kind of just land the building back on top again. And also those building that type of construction, that plot renewal type, also benefits greatly from off-site construction. Volumetric was one that we played about with back in the day when we were testing the efficacy of plot renewal. And again, within that, you can keep a much closer eye on materials, processes, workflows in factories. And when you're doing your LCA, you can calculate that or accumulate all those values much easier, including putting energy monitors on your factory so you can see how much energy is being consumed per unit or per pod or per wall panel, things like that. So it is exactly how you describe it, Jennifer. It's knocking it down, keeping everything from the subfloor down, and then building like for like, but better and more efficient. And only then is knocking down better than deep retrofit.
Thanks for that, John. We've got another question here, and this one's from Nick. And again, it's posed to yourself, John. It's regarding the life cycle assessment. So do you consider environmental effects of the solutions? For example, harmful retrofit materials?
The life cycle assessment can be expanded to include, again, it's like I said at the very start, it depends on where your scope starts and stops. So a really in-depth life cycle assessment, we're looking at all 6 greenhouse gases that affect climate change, but also things like ecology, land use, water use, water treatment, off-gassing, leaching into the soil. And then whenever the materials go off to end of life scenarios, if the only end of life scenario you have is incineration or landfill, then you also look at the impacts going into the ecosystem from that material leaching into the earth. So you can go as deep as you want to, and you can start to bolt on those extra elements of environmental impacts, which include toxicology and land use. And within this area of life cycle assessment, one of the biggest debates right now is land that could be earmarked for mass house building. If that was left to be used for some other agricultural type, like crop growing, for example, which one is actually better? Because yes, you're building houses for the public, but also we're keeping a lot of farming and agricultural processes in country, so the food doesn't have to travel so far to feed the population. It can go that deep, is what I'm trying to say. So it depends where you set your scope. It depends on the KPIs of your project, and it also very much depends on the information available from whatever material manufacturers you're specifying. A lot of them are volunteering to do the EPDs that show the different stages of materials life, but a lot of them just kind of show stage 1A to A1 to A3, which is only whenever the material leaves their factory or processing plant. So data is kind of also helps you decide how far your scope sets and how much of that additional toxicology you look at, which is harmful for the environment.
Thanks for that, John. We've now got a question directed towards Jonathan, and it's from Emma, and she would like to know where we can study for the level 3 O&T qualification.
Oh, hi, Emma. Thanks for asking. I did the course last month. I did it with Moses and colleagues through Historic Environment Scotland up at the engine shed in Stirling. I'll post the link for that into the chat. However, other providers are available. The course, I believe, is available through the Environmental Studies Centre with Professor John Edwards, who may work in partnership with other organisations also to offer that out. I'll stick the link through, and hopefully that will be able to give you an idea of the calendar as far as Historic Environment Scotland is concerned. But I dare say a wee Google of some of the other providers out there should point you in the right direction. It is awarded by the NOCN, so regardless of where you're qualifying or who you're studying through, you should end up with the same qualification at the end.
Thanks for that, Jonathan. We've got another question directed towards yourself. It's with regards thermal imaging, and do retrofit professionals do energy use after completion? Do they look at the ventilation, cold bridging? Do they look to see if they've actually came up with a solution through the retrofitting process?
Yes, that's used. It's recommended. It's guidance, so it's back to the old should within the PAS. It's guidance within the PAS that thermal imaging is one of several techniques which can be used to validate the efficacy of the retrofit program. to identify any thermal bridges or gaps that have been left post-install. It's certainly something that we would conduct to certain archetypes of property, particularly on looking at different projects where you may have a collection of properties of similar construction styles and archetypes, and there may be the coordinator may decide to conduct thermal imaging and other techniques across a reference number of properties. So there is a place for it. Tends to in reality be fairly client-led, and a lot of our role involves influencing the client to ensure that that's within the budget and the scope of works that they're happy for such evaluation techniques to be incorporated in. There are other techniques that are mandatory. So for example, in a Path C job, regardless of what's being installed or the type of property, there's a requirement for mandatory air permeability testing as a minimum pre and post install. That must be done to comply with the PAS. And who knows, maybe in a future iteration of the PAS, we'll begin to see other evaluation techniques becoming mandatory themselves.
Thanks for that, Jonathan. So we've got time to take one more question, and we've got a question here from Tenor, and this is directed to yourself, John. How best to use mass timber in retrofit, like the CLT, glue lam, etc.?
Yeah, good question. We had myself and my colleagues from CIAT have recently collaborated with the Mass Timber Academy. Mass Timber Academy have an amazing resource out there, which I know BEST support as well, which is the use of mass timber. I know that BEST have done a lot in the past 3 or 4 years to really bring that method of construction to the forefront, dispelling myths and demystifying the whole thing. I would say that the best way would be to either extensions or also to do some sort of facade retention type of thing. It depends on the scope and the scale of the project itself, but there is, in terms of the timber and its ability with carbon sequestration, it does have a lot of very good benefits for something we call a sustainable retrofit, but it's going to be something that will be very site specific in terms of can you get the size of vehicle that you need and the reach of vehicle that you need to land some of those larger pieces. And it also depends very much on where those materials and processes are being carried out to make the mass timbers, the CLTs, the glue lams, the nail lams, the dowel lams, all the different lams. I would say at the moment they work really well for extensions, so moving away from steel and using your structural LTs. But there is some examples of the Mass Timber Academy have been looking into this of facade retention and bits and pieces like that. So that's how I've seen them used through BEST projects and other case studies, and they look really well. Especially when you have something with such a large visual effect of sandstone beside something with exposed CLT or exposed nail lam or dowel lam. It looks amazing.
Thanks for that, John. So as we're moving towards the end of today's webinar, I'd just like to wrap up today's session with one final poll. So if you can just spare the next 30 seconds to complete. And I would just like to thank everyone, especially the audience today, for taking the time to join us and for all the important questions. And if we didn't reach any, we'll certainly endeavour to answer them over the course of the next few days. I'd also like to thank our panellists for sharing their excellent presentations and providing an insightful discussion. We'll also ask you to fill in some feedback. We plan to use this for future events and initiatives, so please do complete the feedback you'll receive after the event. And any links in the chat for related sites to stay up to date with the latest state-of-the-art developments in the field. You can contact each of the organisations through the links that we'll provide, whether that be LinkedIn, Twitter, or websites. So that just leaves me to say thanks for attending today, and we look forward to welcoming you at our next event. Have a good afternoon.